Welcome again on the second video on the dimensioning. I am Dr. Ilangovan, professor from the Department of Aerospace Engineering, SNSCT College of Technology. This is the video which is being intended for the students of second year aerospace engineering students of SNS College of Technology. The type of the theory of dimensioning goes like this. There are two things that we have to worry. One is the size, and the other one is the location. Okay, there must not be any ambiguity or confusion when we are dimensioning. So they have to be carefully selected, and the designer so as to avoid the confusion, ambiguity, or insufficiency of the dimensions. Because at the time of making it, when there is a dimension which is missing, then the whole entire thing stops. So one should ensure that the all the dimensions are given, and there are two things that has to be done. One is the size of a hole, and where is the location of the hole. If it is an edge, what it is supposed to be. If it is a curve on the edge, then where is the center point of the edge. Now, if it is a square dimension, what is the distance between the two sides. That those kind of things is what comes under the theory of dimensioning. Now, this one is the size, the second one is the location. This is what I had just said, that the size of these two drawings looks very similar, but when you look at the top view of that, you see that this is a rectangular cross section, and this is a circular cross section, and that is very clearly made here. Here there is no symbol of dia, whereas here there is a symbol of dia here. Now this is these two looks very similar, whereas this is a pyramid when this is a cone. A pyramid has side faces, uh, uh, um, flat faces on its sides, whereas a cone has a circular face. Now the last one is the part of the sphere. So if it is part of the sphere, when you dimension, instead of simply putting a dia 16 there, we put a prefix of S, capital S there, just to tell that um, it is a spherical dia of 16. So for sphericity of the dimensions in 2D has been mentioned here as S here. The next one is the combination of size and location is the theory of dimension. As we said that we try and combine both the size and as well as this and make the dimensions. This is how the dimension drawing will look like. So you have the object, and then you have only the size that has been put here. You have the location alone which is put there, and then once I combine both the size and the location, I have the size location, which is a perfect drawing and with no ambiguity or confusion on this. Okay, so the next one is the systems of dimensioning. We have different kinds of systems are being used in as per standards, as per Bureau of Indian Standard or the BIS. We have the aligned system where all the edges are aligned, and then I can pull out a dimension which is exactly parallel to the size, the flat face. These are the aligned systems. Here, these are the radial dimensions. We pull out the dimensions, and then if you look at this, as it goes down, we will not put the text upside down. We will try to write the text above the dimension line. So here, so that it is easy for us to read it out from the front. Okay, so that is the idea. This is a included angle of 60 degrees. There's an included angle of 30 degrees. Here bottom you have the 30 degrees each here. So we find out where we place the text of the dimensions. So we have unidirectional type where the dimensions are all in one direction. It is all made. Sometimes we try to break the dimension line, and then we try to put the text there, so that all the text are being are kept upright, and then you see the dimensions as compared to the previous one that has been shown. Okay, so here you see the dimension line has been has been broken, and then we place the text in between, which is upright. Okay, so This is in manual drawing, maybe this is easy, but when you're doing it for in the CAD, this will require a lot of extra you know arrangement that has to be done. So generally we can avoid this kind of outdated kind of dimensioning system. Okay, so how do you understand the shape? To understand the shape, etc., has been very clearly given here. If this is a radius, I put R here, R15, and if it is a diameter, I put dia symbol and 15 here. And if this is a flat face, we try instead of this, it is not diameter, but then it is a flat face. So since it is a flat a square peg, so the size of the this one is written as a small square has been put in front and then 15. So it is a square of 15 mm. Okay. This one is spherical radius of 12. This radius is a part of the sphere and it's a spherical radius of 12, and this is a spherical diameter of 25. Okay, so spherical diameter, spherical radius, this is a square dimension, and then this is a diameter and this is a radius. So all different shapes identification symbols are being given here. The next one is the arrangement of and indication of the dimensions. We have various different kinds of dimension here. You have the chain dimension, parallel dimension, combined dimension, progressive dimension, and dimension by coordinate and equidistance dimensioning and the repeated dimensioning. We'll see one after the other now. Now this is a chain dimension. Chain dimension means that from one edge to the next, this one, everything is as per chain, one after the other. Okay, each one has its own advantages, disadvantages, etc. In measurements, we will get to know more about this. Okay, so the chain dimension goes like this. In this method, I have a chain dimension like this, and as I just said in the previous slide. Otherwise, if you have to use the parallel dimensioning, the alternate way is to do parallel dimension. So I'm measuring from this edge to this edge instead of measuring from this edge. In the chain dimension measured by with the subsequent edges, whereas here we take one as a datum, and with respect to the datum we try to put the dimensions, and these are called as parallel dimensions. The placing of the dimensions can be just noted as to how what will be the distance. Initially from this edge we put 10, and then the subsequent can be 8 mm distance. Then you can combine both these parallel dimension and the chain dimension here, and you can have the and you can have both depending on the type of drawing that you are doing it. Okay, so you can also have something called as a progressive dimensioning. Progressive dimensioning is like, is kept from one datum point, and progressively it is there. You see the arrows are just at one edge, so everything is measured with respect to this point. So from this point this distance is so and so, and from this point this distance is at so is being written here. So progressive dimension is being measured always with respect to one datum point, and then progressively what is the distance is what we are measuring. So we will stop here. This has again been a long video. We will meet on the third video of the dimensions. Thank you for staying with me. Have a great day.